this video, we'll take some code for performing a relatively simple task written in an imperative manner and transform it to a more functional and arguably more idiomatic style. Let's get to it. Our task for today is simple. We'll write a function we'll call find that takes two arguments named string and substring, both of which are ampersand strs, aka string slices. The function will search through string and record all the locations where substring is located. We'll represent this with a vector that contains a struct we'll call substring location. Each substring location will record the index of the line, aka line index, and the character index of the substring in that line, aka substring index. The code starts by creating a vector called locations. We'll use this vector to collect all of our substring location structs. We need to mark this vector as mut since we'll be mutating the vector as we push substring location structs onto it. Next, we create another mutable binding called line index, which will keep track of which line of the input we're on. Then we'll call the lines method on string. This returns an iterator over all the lines of the string. For each line, we call the match indices method on string slice, which returns an iterator of matches of a pattern within the string slice, as well as the index that match starts at. We use a for-in loop to iterate through the matches. For-in loops allow us to use patterns to destruct the current item. We can rewrite our tuple so that the first item in the tuple binds to the name substring index. We use a special binding name underscore for the second item, the match substring itself, since we won't need it. We construct a substring location struct and immediately push it onto our locations vector. The last thing we do in our line loop iteration is increment the line index counter. After we've looped through every line, we can return our locations vector to the caller. We're done. Next, we'll take our imperative function and slowly convert it to a more functional style. The first thing we'll do is get rid of the need to manually keep track of our line index. We can do this by calling the enumerate method in our lines iterator. Enumerate returns to us a new iterator that yields a tuple of the item along with the current index. This way we don't have to manually keep track of the line number. Enumerate will do it for us. Next, we'll want to remove the need to manually update our locations vector. We can achieve this by changing the inner loop to use the map iterator function instead of a for-in loop. Looking at the docs for the map method, we can see that it takes a closure and creates a new iterator which calls the closure for each item. In other words, map transforms or maps one iterator into another. We'll want to change our match indices iterator into an iterator of substring location structs. Making this change is pretty straightforward. We can even keep the pattern destructuring we used in the for-in loop in the argument to our closure. We can now also get rid of manually pushing our structs onto the locations vector. Once we've made the change, we see a small problem. We have a warning telling us that we're not using the result of mapping our iterator. We'll address this in the next step. As we iterate over the line index line pairs in our outer for-in loop, we transform them into iterators of substring location structs. But then we simply toss these iterators away. This is why we're getting a warning. What we'd like to do instead is to transform the pairs into iterators of substring location structs and then keep the iterators around. We can do this by using the map method we're already familiar with. Once we've done that, we'll have a collection of collections of substring location. The last thing we'll want to do is flatten this collection of collections into one single collection. This is done using the flatten method. Going back to the code, we can make the change rather easily. First, we add the map method to map from our tuples to the collection of substring locations. And then we use flatten to turn the collection of collections into one single collection. After we've made the change, we see we have an issue. The error says the closure we're passing to the inner map function may outlive the current scope, and thus it may outlive the borrowed value line index. By default, Rust closures try to be as conservative as possible when it comes to capturing items from their environment, by borrowing items from the environment instead of taking ownership. The use of the word borrow might be a bit confusing, since the closure isn't magically taking an ampersand reference to line index. The line index binding on line 11 and line 15 are of the same type, usize. The difference is that the binding from line 11 owns the value it is bound to, meaning that when the binding goes out of scope, the value it refers to will be destroyed. The binding on line 15 is simply a borrowed version of the value from line 11, meaning when it goes out of scope, nothing happens. The value continues to exist. This is a problem. When the outer scope ends, the value line index is bound to will be destroyed, but the borrowed binding from line 15 will continue to exist in scope inside the inner closure. If this were allowed to happen, we could still possibly use the value even though it's been destroyed. Rust doesn't allow this. Instead, we need the closure to take ownership of line index. We want the binding on line 15 to be responsible for when the value is destroyed, not the binding on line 11. In other words, we want to move line index into the closure. Moving the value into the inner closure means the binding in the closure now owns it and is responsible for destroying it. In other words, line index on line 15 is no longer a temporary borrowing of the value, it owns that value. We can use the move keyword at the beginning of the closure to tell the compiler that we want it to move values it captures into the closure and not borrow them. Lastly, we need to turn our iterator of substring location structs into a vector. We can do this by calling the collect method, which collects all items in an iterator into a concrete collection type, like vector. We can then scroll up and delete our locations vector. We can improve this slightly by using the flatMap method, which does the same thing as performing a map and then a flatten. And we're done. Thanks for watching.